Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back to the fifth and the last video for the AOT Grade 11 Advanced. In this video, we will go over the writing part, questions 21 to 25. So let's get started. As you can see, this is the free response question 21, Module 5, Lesson 2. Solve exponential equations in one variable. Right? So before we start, ya shabab, let me just remind you with something very quickly. If I have, for example, here, like let's say 2 to the power of x equals 2 to the power of y. In this case, what you can tell from this equation here, as long as that we have equal sign, it means both sides are equal. So I will look at the bases here. As you can see, the base here is 2 and the base on the other side is 2. So if the base is equal, to make this equation correct, the exponent must equal the exponent. So if the base equals the base, the exponent equals the exponent. So in this case, I can say that x equals y. So in the coming or the following type of questions, all what you will need to do is to put the bases equal so you can equate the exponents. This is how the question work. Let's see. As you can see here, questions can be very simple. Like I don't think this will happen in the exam, but inshallah it will. But let's see. For example, as you can see, what is the base here? It's 25, while on the other side the base is 25. So this means bases are equal, so you don't have to do anything with the bases here, which you will see it will change starting from the next question. So let's see, if the base equals the base, we said, so the exponent equals the exponent. So in this case, I will equate the exponents. So here we have the exponent on the left side is 2x plus 3 equals the exponent on the right side is 5x minus 9, and this is an equation that you need to solve to find the value of x. So what I will do, usually I will bring x to the left side, combine all the x together and send the 3 to the other side. So I have here already 2x. If I will send this 5x or bring it to the other side, it will be negative 5x equals, here we have negative 9, send positive 3 to the other side, it will be negative 3. Now 2x minus 5x is negative 3x. Negative 9 minus 3 is negative 12. To find the value of x here, we will divide by negative 3, divide by negative 3 on both sides. So we will cancel these. So x equals negative 12 divided by negative 3 is a positive 4. And that's it. Right. In question 2, things will change a bit, and then later we will have a higher level as well. We will go one by one to see the differences. Now the base here is 9, while the base on the other side is 81. So the bases here are not equal. So the bases are not equal. In this case, you should be thinking in that way. If the bases are different, look at the bigger base here, which is 81. Now ask yourself, can I rewrite 81 as the smaller base, which is 9 power of something? Like, think of this. Can 81 be rewritten as 9 power of something? If yes, the question is still very easy. So let's say 81 of course could be written as 9 to the power of 2, correct? In this case, what I will do, I will replace 81 by 9 to the power of 2 and simplify and solve the question. Let's see how it works. So on the left side, I don't want to change the 9, so it will be 8x minus 4 equals, now I will replace 81 by its value 9 squared, so 9 squared. But don't forget, when you replace this, don't forget to put a bracket, then 3x plus 6 is the power for the 81, or the exponent, we will put it here. Now, before we go, I will just revise something with the power rules here. If I have x to the power of 2, all to the power of 3. So we have a power to a power. What I would do in this case, ya shabab, remember we do not add, we multiply the exponents. So 2 times 3 so it will be x power of 6. All right. How to apply this here? Let me just remove this now. How to apply this here? In this case, this means if you will multiply the 2 with the 3x plus 6, but because we have here a plus, it means I will multiply 2 with both terms in the exponent. So still, again, the left side, I will not change anything. This one will be 9. Then I will multiply 2 over the exponent, all of the terms in the exponent. 2 times 3x is 6x. 2 times 6 is 12. Now, what do you see here? The base now equals the base, and this is, if you remember when I said at the beginning, this is your target to put the bases equal. In this case, I can equate the exponents. In this case, I can equate the exponents. So now, 8x minus 4 equals 6x plus 12. Bring the x together and send the numbers together, so it will be 8x, 6x will go to the other side, will be minus 6x. I have here 12, negative 4 will go to the other side, will be plus 4. 8x minus 6x is a 2x, 12 plus 4 is 16, divide by 2 both sides, so x equals 16 divided by 2 is 8, and here is the solution. Let's see how the questions here are changing. Actually, I will not solve this one because it's still exactly the same. Look, 4 and 16 are the bases, they are different. What you will do is to think of the bigger number. Can it be rewritten as 4 power of something? The answer is yes, it could be replaced by 4 to the power of 2, and we just do the same thing here. Let's see, this question is a bit different in this case. Because here we have 4 and here we have 8, so I will think 8 is, can I rewrite 8 as 4 power of something? The answer is no. In this case, we will have to change both bases to another smaller factor can be written as power of something, which means it's very obvious 4 and 8. 4 could be written as a smaller number, which is 2 to the power of 2. 8 could be rewritten as well with the base 2, but to the power of 3. So in this type of questions, we will replace both 4 and 8 by 2 power of 2 and 2 power of 3 in the same place. So let's see, the 4 now will be replaced by 2 to the power of 2. Don't forget, we put a bracket. Then I will leave the power, 3x minus 3, equals 8 will be replaced by 2 to the power of 3, 2 to the power of 3. And the exponent is 4x minus 4. Now, don't forget, when we multiply يا شباب by both terms. We multiply by both terms if you have 2 terms or more. But if I have 1 term, I just directly multiply. Now, so it will be 2 to the power of 2 times 3x is a 6x. 2 multiply negative 3 is negative 6, equals, here we have 2 again. 3 multiply 4x is a 12x. 3 multiply negative 4 is negative 12. Now, and only now, as you can see, the base equals the base, so the exponent equals the exponent. So now I can equate the exponents and solve the equations to find the value of x. So we have here 6x minus 6 equals 12x minus 12. Remember, we bring the x together, the numbers together, and solve. 6x, 12x will go to the other side, will be negative 12x, equals, here we have a negative 12, negative 6 will go to the other side, will be positive 6. Now 6x minus 12x is negative 6x, negative 12 plus 6 is a negative 6, divide by negative 6 on both sides, these will be cancelled, so x equals positive 1. Okay شباب. This is how the question work. In the coming questions, I will not be solving, I will just show you how you will change both numbers. For example, this 9 and 27. Ask yourself every time, can I rewrite 27 as 9 power of something? The answer is no, which means I will change both. So this 9 could be rewritten as 3 to the power of 2, while the 27 could be rewritten as 3 to the power of 3. We put the bracket and we write the same power, put the bracket, and we write the same power, then multiply over the bracket, equate the exponents while the bases now are equal, 3 and 3, and solve the equation. For 125 and 25, the same thing. Can 125 be rewritten as 25 power of something? The answer is no. So in this case, I will change both. Very obvious, it's a 5 power of something, 5 power of 3, and here 5 power of 2. Put the bracket, exponent, put the bracket and the exponent, like here and there, then multiply over the bracket, and then solve the equation. Alright? So this was question 21. Now the free response question 22. Module 6 lesson 2. Solve logarithmic equations using properties of equality. Simplify and evaluate expressions by using the properties of logarithms. So as you can see here, let me just start with something the same as what we have done with the solving exponential equations. If I have log, let's say x to the base a equals log y to the same base a. So as you can see, the same thing, Yashab. If I have equal sign here, it means both sides are equal. So as long as I have log to the base a and log to the base a on both sides, this can be equal if x equals y. So I can say from this that here x equals y. In this case, I will equate both x and y and solve the equation. Again, this happens when the bases are equal. So let's see here. As you can see, in all questions in this part, the bases will be equal. So as you can see, this is log base 4, this is log base 4, which means these two quantities must be equal. So what we will do, again, we will just equate them. It's very similar to the previous question with only one change I will tell you in the end. So it's a 2x to the power of 2 minus 4 this side equals 2x on the other side. Okay. What makes this question different? Because this, as you can see here, we don't have x and x on both sides. We have here x to the power of 2, which will lead us to a quadratic expression. This means I will bring only the 2x to this side and make it a 0 in this side and solve a quadratic expression. So what will happen here is it will be 2x to the power of 2. Bring 2x here, it will be minus 2x. Then we have minus 4. Now it leaves on the other side 0. Someone will ask why I didn't write 2x power of 2 minus 4, then I bring the 2x as a negative 2x. The answer is I want to keep the standard form of an algebraic expression. If you remember, it should be x power of 2, x power of 1, x power of 0 or no x. So I'm just keeping the order. Start with x power of 2, bring the x or the 2x in this example, then put the number with no x equals 0. When we move this to the other side, it leaves a 0 here. It leaves a 0 on the other side. Now we have a quadratic expression, but you have to remember, Shabab, you need to simplify, as this is the writing part. If you will solve it with the calculator directly, you remember x power of 2x and no x, you use the moot 53 on your calculator and you put the values of a, b and c. If you remember, on the calculator it's a x power of 2 plus bx plus c equals 0. You put the values of a, b and c on the calculator, and the calculator will give you the two values of x or the one value in some special cases. However, in this example we have here you have to check if there is a common factor. So we have here 2, 2 and 4. All of these numbers can be divided by 2. So what we will do before we continue or put it on the calculator, I will divide all terms in this expression by 2, as there is a common factor here as 2. So we divide all the expression by 2. So what will happen here, 2 will be cancelled, so we have x to the power of 2 only. 2 will be cancelled, so we have negative x. Negative 4 over 2 is a negative 2, and the answer 0 divided by 2 is a 0. Now you can put it on the calculator, a, b and c. So it's a 1, negative 1 and negative 2. It will give you two solutions. Don't forget you change the numbers on the calculator before you put it here, or to be honest, I prefer that you are not using a calculator at all and solve it manually. if you can, here we have a 2, it comes only from 2 multiplied by 1. If I have a negative here, it means we should use different signs. So if it's a negative in the middle, it means I will give the negative to the bigger number and positive to the smaller one. Now, in this case, if I have two factors multiply and the answer is 0, this means either x minus 2 equals 0 or x plus 1 equals 0. So one of these two factors must be 0 to give me the answer is as 0 here. In this case, we can say that x equals 2, and on the other case here, it will be x equals negative 1. طبعا please be careful. In this type of questions, most of you, and remember this, will leave the answer like this in the exam, and in this case, ya shabab, you will not take the full mark. Why is that? Remember, ya shabab, before I continue and show you why, I want you to use your calculators and try this with me. If I'm putting for any question, log 5 base 3, just an example. You will find a very long decimal, but as anyway, this you still have an answer. But if I will put here minus 5 and put it on the calculator, what you will see? You will find an error, or which means there is a problem with this expression. Why? Because we said in the logarithms, ya shabab, we cannot have negative values. Inside the log here, we can't use negative values, which means in this case, I have to check both of these values. If any of them will give me a negative, it will not be correct. Now let me remove this, and which means after finding the values of x, you still have an extra value here, is to check both solutions. Which one will be accepted, which one will be rejected. To do this, actually you can do it anyway, like you can use your calculator and just substitute by 2 here and substitute by negative 1 and check. So what I will do, I will check with 2 first. So if it's a 2, what I will say, I need to check these two values, both sides. Right. For example, I will start with this one here. When I'm substituting by 2, it will be 2 multiplied by 2 to the power of 2, which means I replace x by 2 in the first example on the left side here, minus 4, and solve this with the calculator. So it will be 8 minus 4, which is a 4. What I care about is that this is a positive, so I don't have a problem with. However, you must check both sides. So for the other side, so I will do 2 multiply by 2. The answer is 4, which is positive, and which means I don't have a problem, so 2 here will be an accepted solution. So we can say here at x equals 2, I will accept both solutions. Right. Now we will check when x equals negative 1. Again, I will do the same thing by replacing x by negative 1 on both sides and see. So what I will do, actually shabab, if there is a side which is very obvious, it will give me a negative. In this case, I don't have to check the other side, because if one of these sides is rejected, I don't have to check the other one. Even if it's accepted, I will not accept the whole value. So for example, here we have a 2x. So what I will say, 2 multiply a negative 1. The answer is negative 2. As long as this is a negative, this solution is rejected. So I will go under this solution. I will write rejected. So this solution is rejected, which means in this case what I will write x equals 2 is the only solution for this equation. So x equals 2 is the only solution for the equation. So you will take the mark by showing, even if you will do like this one, accepted, or put a tick and write here rejected, and that is x equals 2 is the only solution for this question. In this case, you will take the full mark. So Ishab, in this type of questions, you will solve it as we explained, but don't forget, this is the most important step here in the question, is to check both solutions, because I'm telling you in advance, a lot of students forget to check the solutions if they are valid. Okay? Right, let's see the second one here. All right. Let's see this one here, shabab. So the same thing, as long as log equals log here, same base and same base, which means these both two quantities are the same. which means I will equate them. X power of 2 minus 6 equals in this side x. So I equate both logarithms here. طيب again يا شباب we will bring x to this side to form a quadratic expression. X power of 2 x power of 2. Remember يا شباب we put the x first. So we bring the x, it will be minus x, and we have a minus 6 equals 0. So why we move the x first before I write the negative 6? To keep the order of the quadratic expression in a standard form. So now there is no common factor as long as there are no numbers here like the 1 and 1. So I don't have to search for or look for a common factor. So I will directly factorize. X squared will be x and x. 6 is coming from 6 multiplied by 1. If the answers are, if the sign here is a negative, it means I'm looking for the difference is a 1. So in this case, 6 multiplied 1 is 6. However, the difference is not a 1 here. The difference is not a 1, which means I can choose another value that can give me a 6, which means, let's say, 2 multiplied by 3. 2 times 3, the answer is 6. The difference between them is 1. The difference between 2 and 3 is 1. So this is how I factorize manually without using the calculator. And if the sign in the middle is negative, I will give the negative to the bigger number and the positive to the smaller. You can still do it with the calculator using A, B, and C values like this quadratic expression, mood 5, 3. But you will find the answers on the calculator. X equals negative 2, you will put it plus 2 here. X equals positive 3, you will change the sign as negative 3 here. 2 factors multiplied, the answer is 0. This means x plus 2 equals 0, or x minus 3 equals 0. From here, x equals negative 2. Let me write this again. X equals negative 2, and this is the first solution. And from here, x equals positive 3. Right? Now, don't forget, ya shabab, the last important step is to check both solutions. So what I will write here, at x equals negative 2, and I will check. I will replace x equals negative 2 here, so I will write negative 2, it's x squared, so negative 2 squared, minus 6, the answer will be negative 2 squared. Don't forget to put the bracket when you're using the calculator, is a positive 4, so the answer when you will use your calculator to simplify this, it will be a negative 2, which means this will be rejected. Do I have to check the other side? The answer is no. So directly I will write here, this is a rejected solution. All right, I will not use it or put a cross, which means it's a rejected solution. Now I will check the other solution. So I will write here at x equals 3, and I will check both sides. So now replacing x by 3 here, it will be 3 squared minus 6. 3 squared is 9, minus 6 is a positive 3, so the answer is positive, accepted. I will choose the other side, it's only x, which means only I will replace x by 3, which is still positive. Both works, both positive, which means this answer is accepted. So what I will write here, x equals 3 is the only solution. For example, if I check both and both works, in this case I will accept both, so it's different. But as I can see here, all the examples we solved, one is accepted, the other rejected, but it doesn't have to be like this. Maybe both will be accepted, so you have to check. If one of them gives you a negative in both or in any of the sides, I will reject it, while the others will be approved or accepted. Now let me see if there is anything different. The same thing, as you can see, log 3 equals log 3, so I will equate both quantities here. Same thing, log 4, you just equate both quantities and solve the equation exactly the same way. Nothing is different at all. All right, now we have a different type of questions, and remember, ya shabab, in this question he will provide you with some values or given values of logarithms. Log 2 to the base 4 equals 0.5. Log 3 to the base 4 is approximately equals 0.7925. Log 5 to the base 4 is approximately equals 1.1610. In this case, ya shabab, in this type of question, if he provided you with logarithms and their approximated values, do not use, if you remember, do not use your calculator. What does it mean? If you will use your calculators, for example, to calculate log 5 to the base 4, it will give you a very long decimal, all right? Here he wants you to use only this approximated version in this question. So in this case, don't use a calculator. You must be using the given values in the question, all right? In this part, ya shabab, as you can see, it's a log base 4, log base 4, and log base 4, and he will ask you all the questions by the same base type. So that the problem here will be 30 is not shown in any of these. However, I can change 30 and rewrite it using 2, 3, and 5, maybe 2 of them, maybe all of them. It's different from a question to another. So let's see. First of all, ya shabab, I have to factorize the 30. We have two methods to do this. I will explain both and you can choose your own way. Think, how can I rewrite 30 in the smallest factors or the prime factors? First of all, I will start by 2 times 15. So 30 could be rewritten as 2 times 15. 2 is a prime number, so I can't split it more. However, 15 could be rewritten as 3 multiplied by 5. Now, all of these factors, 2, 3, and 5, are prime numbers, so I will stop. 2, 3, and 5. This means I can rewrite 30, as 2 times 3 times 5, and this is what we will do. What about the other method? If you remember, the prime factorization, we put a line that way, and we write 30 on the left side, and we use here the division by but prime numbers only. So I will start from the 2 and move on. Divide by 2, the answer is 15. I can't use 2 again, so I will use the next prime number, which is 3. The answer is 5. I can't use 3 again, but it's very obvious I can use 5. The answer is 1. Once you reach a 1 here, it means you stop. So 30 could be rewritten by 2 times 3 times 5, which is the same answer here. So you can choose your own method to solve this question. Now let me just remove this and start solving the question now. So I know that now 30 could be rewritten as, I will write here 30 could be rewritten as 2 times 3 times 5. I will replace it here. So what I will write log to the base 4, replace now 30 by its value, 2 times 3 times 5 times. Before we move on, let me remind you with one of the properties, ya shabab, if I have log to the base a, or whatever the base, of x times y, if I have a multiplication here, if you remember, we can split it into the logarithms for both of them, but we will use add, which means I can rewrite this as log x to the base a plus log y to the same base a. So we can, again, if I have log x times y and we have a product here or a multiplication, we can split it into 2 logarithms, x plus logarithm of y to the same base a. All right, so now let's go back to the question now. And if I want to rewrite this using this property, I will write log to the base 4 2 plus log to the base 4 3 plus log to the base 4 of 5. This is how it works. We split this into these 3 logarithms using the same base. Now, what will happen is you will find log 2 base 4 is given in the question, and this is the answer. Log 3 to the base 4 is given in the question, and this is the answer. Log 5 base 4 is given in the question, and this is the answer. So what I will do now, I will replace them, but the value is given in the question, which means I will replace this by 0.5 plus the second one here is 0.7925, and the last one, if you can see this in the question, is 1.1610. Only, ya shabab, in this case I can use the calculator. I just will be put an equal sign here. So when you add these in this part only, and this in this part, ya shabab, and this part only, you can use now your calculator just to add these. So I said don't use a calculator when you are like doing log 3 base 4. Don't use the calculator in this part. No, use the given values in the question, and in this case you can just add them with the calculator in the last step. يبقى here I can use the calculator, no problem to add. It will be 2.4535. okay شباب, just the calculator in the last step, and that's it. All right, now let me do another one here. The same thing يا شباب, we have here the number is 20, so this 20 could be rewritten, it's up to you. I will use the 3 method and the prime factorization method. 20 could be rewritten as 2 multiply by 10. 10 could be rewritten by multiply by 5. So 2 multiply by 5. So in this case 20 could be rewritten as 2 multiply by 2 multiply by 5. So I will rewrite it here. So 20 could be rewritten as 2 multiply by 2 multiply by 5. However, if you have a common factor, or sorry, a repeated factor, we will rewrite it using the power. So it will be 2 power of 2 multiply by 5. This is important يا شباب to remember. If I'm using a prime factorization, for the ones who prefer to use it, I will write 20 divide by 2 is 10. Can I use 2 again? Yes. So divide by 2 is 5. No longer 2, it's a divide by 5 equal 1, which means from this one it will be 2 to the power of 2 because it's a repeated factor, and here we have 5, so it could be rewritten as 2 to the power of 2 multiplied by 5. Okay. Alright guys, so I can rewrite 20 now as 2 squared multiplied by 5. Already we know this information. So I will rewrite the question again. I will say equals log to the base 4 of 2 squared multiplied by 5. We will use the same property. If I have a multiplication, I will split it into 2 logarithms with the base 4 of 2 to the power of 2 plus the same logarithm to the base 4 of 5. Now, if you remember the property of the exponent, if I have in the logarithm an exponent, I can put it back outside, multiplied by the logarithms. This is what I will do here. So it will be, a 2 log 2 to the base 4 plus log 5 to the base 4. Alright, now ya shabab, in this case I will use the as you will notice here we have log 2 base 4, log 5 base 4, which means I will use the 5 and the 2 only. I don't have to use all of them. For example, here I don't have the 3, so I have only 2 factors, 2 and 5, so I will use these 2 solutions. So I will write 2 multiply by log 2 base 4 is a 0.5, while log 5 base 4 is 1.1610. And if you will add them, if you remember we said in this part you can use a calculator, no problem with this. So the answer will be 2.1610 or 2.161. It's still like we can remove the 0 here, and actually you don't need the calculator as all, as 2 times 0.5 is a 1, plus this I will just add 1 here to the whole number. As you can see, these questions are the same with only one change. Here we do not have a multiplication, we have a division. If we have a division, what we will do, actually, but I will not solve this one because it's an easy one. Actually, it will be directly, if I have a division, it will be rewritten as 2 to the base 4, but if it's a divide, we will use minus, not a plus, log 3 to the base 4. يبقى again يا شباب, if I have a division, we use a minus, not a plus. In multiplication, if you remember, if it's a multiplication, we will use a plus here. If it's a multiplication, we will use a plus, while if it's a 2 over 3, it means a division, we will use a minus, like as you can see here. Alright, type. In this case, actually I will not solve. You will just replace this by 0.5. You will replace this by 0.7. It means you will use only these 2 values here, replace them, put it on the calculator and solve. I will solve this one because it's a more advanced type. In this case, again, we have here in this question a division, so I will split it into log 4 to the base 4 minus log 3 to the base 4. Actually, this question has 2 ways to be solved. I myself will prefer to say that I will show you both solutions here. I will split the question here. I will solve both in both sides. So I will rewrite it log 4 to the base 4 minus log 3 to the base 4, and I will write it again here, log 4 to the base 4 minus log 3 to the base 4. The first method that I know that log 4 to the base 4 يا شباب equals 1 minus log 3 to the base 4. I will bring it from the question. Log 3 to the base 4 is 0.7925, and you will just, like I would say, equals, and you will do it just with the calculator. It will be 0.2075. Type. On the other side here, log 4 to the base 4, I will look at this 4 could be rewritten as 2 to the power of 2. So I will rewrite it, يبقى log 2 power of 2 to the base 4 minus log 3 to the base 4. So I know again 4 could be rewritten as 2 to the power of 2, and remember the property of the exponent. I will bring this to outside, so I will rewrite it as 2 log 2 to the base 4 minus log 3 to the base 4. Now we have log 2 to the base 4 here, and we have log 3 to the base 4 here as well. So I will just substitute 0.5 minus log I will just write the value, so it will be 0.7925, and we subtract, don't forget to put like equal sign here, so the final answer will be 0.2075. Okay شباب, so this is how the question work. All of these questions are the same. We can have a slight change here. For example, here I have log 9, so when you will factorize the 9, and actually I don't need to. 9 I know directly, it could be written as 3 to the power of 2. It could be written as 3 to the power of 2. So what I will do here, I will rewrite it as log 3 power of 2 to the base 4, and don't forget I will use the property of the exponent. I will put the 2 outside. It will be 2 log 3 to the base 4. Now it's a 2 multiply log 3 to the base 4. I have it here, which means I will replace it by 0.7925. Do it with the calculator, find the result, whatever the answer is. Same thing here يا شباب. This 8 could be rewritten as 2 to the power of 3. So I will do what I will do. It will be log 2 power of 3 to the base 4. I will replace 8 by 2 to the power of 3. Use the exponent property, put the 3 outside, so it will be equals 3 multiply log 2 to the base 4. Log 2 to the base 4, I know it here, it's a 0.5, so it will be 3 multiplied by 0.5. You can do it with the calculator. This one is easy, it will be a 3 over 2, but anyway, you will use the calculator to do. Same thing يا شباب, 25 will be 5 to the power of 2. You will put the 2 outside, then log 5 you will find it here. As you can see, this is the log 5. 27, 3 to the power of 3, put the 3 outside, then use the value from log 3, which is this one. The same thing. Type 125 could be rewritten as 5 to the power of 3. Remember, 625 could be written as 5 to the power of 4. Every time you will put the exponent outside and use the given value in the question, like in log 5 I will use this value here. Last two, I think here, 81 could be rewritten as 3 to the power of 4. Type 243, you can still try to factorize, or you can try 3 power of something. So actually it's a 3 to the power of 5, but if you don't know this, I can still يا شباب use the old method of factorization or prime factorization. I will try, can I divide this by 2? The answer is no. Can I divide it by 3? You can try your calculator. The answer is yes. It's an 81. Divide by 3 again, it will be, I will not leave the 3 until I cannot divide by it. Divide by 3, it's a 27. Divide by 3, the answer is 9. Divide by 3, the answer is 3. Divide by 3, the answer is 1. Once it's a 1, I will stop, which means 3 times 3 times 3 times 3 times 3, 5 times, which means 3 to the power of 5. And I do it here directly. Okay, شباب? Now, the next question, still in the free response section, question 23. Module 7, Lesson 3, Graph and Write a Reciprocal Functions by using Transformations. Alright, so just to remind you very quickly, if I have like two axes, x and y, so this is the x-axis and this is the y-axis, the reciprocal function is usually like the parent function is y equals 1 over x. So to graph it, we graph two curves like these in the quadrant 1 and quadrant 3 with two vertical and horizontal asymptotes at a which are the x and y axes, or y equals 0 for the x and x equals 0 for the y. The most important thing here is that what is the center of this graph? So the center of this graph is always the origin O, which is 0 and 0. Just keep this in mind for the next question, because this center will change and will be the key of the solution for the transformed graphs in the coming questions, as you will see inshallah. Alright, so as you can see here, identify the value of a, h and k, then write a function for the graph g of x equals a over x minus h plus k. So if you remember, Shabab, we said this is the general form of the transformed graph. Remember, the h value as usual is in a charge of moving as long as it's connected to x, to the right or to the left, which we call as the phase shift, and it's a minus because always we change the value or the sign of the value of h. The k here is in a charge of moving up and down, and we do not change the value. And a will be in a charge of two things. If you remember, a could be positive or negative. If it's a positive, the graph will be, if it's a positive, the graph will be drawn in the first and the third quadrants, while if it's a negative, it will be swapped or flipped or reflected to quadrants 2 and 4. So this is what the negative sign or positive sign will affect the graph. The second thing is it will be in a charge of like the dilation of the graph. Either it's a compressed or stretched. It depends on the value. The question is way much easier than this, so let's see how it works. I will just give you some steps here. So the first thing, ya shabab, remember we said that the normal center is always 0 and 0. The first step to solve this question, or to which will be very easy to find the value of h and k, is by finding the new center. The new center, the new center will be always represented by h and k, and we will see this in the graph in a minute. Now, part 2, use any point on the graph or on the curve anywhere, and but just be sure it's an accurate point to find the value of a. These will be the steps we will follow when we will start solve this kind of questions. Now let's start. As you can see here, Shabab, the graph, it's very obvious. It's shifted to the right some few steps. Don't worry about this, or just what you need to find here is where are the intersection of the vertical and the horizontal asymptotes. As we can see, this is the vertical asymptote and this is the horizontal asymptote. These two lines intersect at this point here. Now, then I want to find the coordinates of this point of the intersection, which is the new center. As you can see, x here is between 4 and 6, which means x is 5, and y is 0. It means the graph is just moved to the right and not moved up and down. Usually, Shab, when you write this, we know that the new center will be always h and k. So I know now that a h equals 5 and k equals 0. In this case, I will substitute h and k in the equation. G of x equals, I still don't know what is the value of a, and we will write here x minus 5, x minus h is 5, plus 0. As long as this is plus 0, I don't need to show this. It's only this part here. So the first step is done, finding the new center, h and k, from the graph, the intersection of the vertical and the horizontal asymptotes, and label them h and k, so you can simply find the values of h and k. Step 2, use any point on the graph to find the value of a. You will see in the other examples, in the coming examples, he will provide you with the point like on the graph in some examples, as you can see here, like for example -6 and 3, or in our example here he didn't mention any point, right? So it's not shown on the graph. In this case, you have to choose your own point to substitute, and any point will be a correct one to use. However, when I will choose a for example, can I choose a point somewhere here, for example? Actually, I still can, but please don't. When you choose a point, always choose an accurate point. It's coming from the intersections of the line of the grid, like this one, for example, here. It will be a very accurate point, so use it, not to use the decimals or approximated values. Now, what are the coordinates of this point? In this case, it will be, go to the x first, it's a 4, then go to the y, it's a 2. So the coordinates are 4 and 2. Then I will label them as x and y. So now I will write here, use the point, this point is 4 and 2, and I will label it for myself x and y. Now I will substitute in the function here that we reached in the previous step with the x equals 4 and the y equals 2. The question is here is that, do we have a y here? The answer is yes. We know that g of x or f of x or k of x, whatever the function is, it's the same as y, correct? So I will replace g of x or y by 2. So it means 2 equals a over, now the value of x is given here as 4 minus 5, which means 2 equals a over 4 minus 5 is a -1. And to find the value of a here, we will just multiply the -1 by 2. So a equals -2. Okay, now as long as I have the value of a, I will put it back all the way here. So it will be g of x equals, now I know the value of a, which is -2, over x minus 5, and that's it. This is the function for the given graph here. Okay, Shab? We find the new center, then we use a point on the grid to replace by x and y to find the value of a. Then the last step here is to substitute h, k, and a, and write the function. Okay, now let's see this example here. So again, Ishab, what I will do at the beginning, I need to identify where is the new center. I will look at the vertical asymptote, the horizontal asymptote. They both meet at this point here, and I will write the coordinates of this point. We go to x first, it's between 6 and 8, which means this is a 7, a value of 7, and this one here is a -8, so 7 and -8. I will label it as h and k, so you can write this down. So h equals 7, k equals -8. Okay, now I will go back to the function and substitute by h and k. So g of x equals, I still don't know the value of a, x minus h is 7, plus k, it means plus -8, which means -8. So I put the value of the k directly without a change, but look, h is 7, so here it's a -7, k is -8, I do not change. Then this is the first step done. Now I need a given point, so I will say use the point to replace x and y. Now I will go to my graph. He's providing you with the 5 and -9 here as the given point. 5, it should be like 5 here, and -9, which means this point, and the -9 here. But I will choose another point to show you I can choose any point to solve. However, if he provided you with a point, I must use it. But if I used another one, to be honest, it should not be wrong, but if he provided you with the point, use it to be sure. Maybe when you will write the another point, you will write it in a wrong way, so it will lead to a wrong answer. So if you provided you with a clear point here like 5 and negative 9, but they should write it here like this is a 5 and negative 9. I think it's a printable mistake. They write it on this side and they put the point somewhere wrong here. This point is a 5 and negative 9, and I will label it as x and y. Don't forget y is the same as g of x here. So in this case I will replace y by a negative 9, so I will write here negative 9. A, I still don't know it. X is a 5 minus 7, and we have here minus 8. Negative 9 equals, I will just simplify this. 5 minus 7 is a negative 2 minus 8. Or I will move the negative 8 to the other side. It will be negative 9 plus 8 a over negative 2. I will move negative 8, it will be plus 8, negative 8, it will be plus 8 on the other side. So the answer here is a negative 1 equals a over negative 2. I will just multiply the negative 2 by negative 1, so the value of a equals positive 2. Now I will write the function. I now have the value of h, the value of k, the value of a, and actually I don't have to think of this again. I just will replace a here, so it will be g of x equals the value of a. Now I know it's a 2 over x minus 7, and we have here minus 8. Right? So this is how it works. So in all questions, ya shabab, I will find the center, which is h and k. For example, here I will label it as h and k, and then I will have a given point like this one, it's x and y, and follow the same steps every time. I don't think we have anything different here, and that's it. Alright guys, question 24, still in the free response, module 8, lesson 4, analyze standardized data and distributions by using z-values. First of all, before we start solving the question, I want to go very quickly over the z-values and the standardized data. So as if you remember, ya shabab, we usually used the normal distribution curve, and this will be the x-score. It means before standardizing or coding the data. And we know now that we have if the mu, which represents the mean, the mu which represents the mean is usually will be exactly in the middle, and we know that if every time I will add one standard deviation or either subtract from the other side, it will be like mu plus sigma, mu plus 2 sigma, mu plus 3 sigma, and from the other side mu minus sigma, mu minus 2 sigma, mu minus 3 sigma. This will provide you with the distribution of the percentages under the curve, and we said, ya shabab, two very important things. What the area under the curve here represents. The area under the curve here represents probability. Just keep this in mind. So the area under the curve here represents probability, which means the total area under the curve, which means the total area under the curve must equal to 1, because the total probability must be 100% or 1. Right. The question here is will be very simple if I'm stopping anywhere either on these lines. Like let's say, for example, if the mean score, let's say if the mean score of a set of data, just an example, equals 20, what is the probability of finding the 20? Or what is the probability of 20? So if I want to calculate the probability of 20, we usually use the area to the left of the curve. Remember, ya shabab, we said this earlier. If I'm stopping either anywhere, not only at the mean, anywhere on the curve, the area always given representing the left side, not the right side. Right. If I'm now stopping at the mean, which means exactly in the middle, this means it's represented by the area under the curve, sorry, on the left side. So I know that if I'm stopping in the middle, this area will be represented by a 50%, because if you are in the middle, all the left side will be 50%, while all the right side will be 50%. Okay, now let me just remove this now. Like, what if I'm not standing on the exactly in the middle? For example, let's say I will just add one thing to the question here. If I'm giving you the value of sigma, and let's say the value of sigma equals 2, which is the standard deviation, now I can find all the numbers here in this case. So for example, if the mean is mu is 20, so here is 20, so mu plus sigma means 20 plus 2, this will give me 22 plus 2, 24, 26. On the other side, subtract sigma, 20 minus 2 is 18, 16 and 14 every time we subtract 2. Now sorry, let me ask you a question. What is the probability of 18 in this case? So it's very obvious. I will go to the x value. X value means the raw data, like the normal values, which is 18. I can know that 18 is standing on this line here, right? Which means I will find the area on the left side of the curve now. Now, ya shab, I know if this side, all of this side equals 50%, now I will not take the 34, which means the remaining side or the remaining area under the curve here will be like 50 minus 34. This means the probability is now, yes, 16%. So the probability now is 16%. So we can calculate it by any other ways, like by adding the remaining percentages here. But don't forget, Shab, there is an area here, it's not shown, 0.15%. 0.15%. All right. I can use the subtraction, it's better. So I know this side is 50. I will not take the 34 because I'm starting from here and go to the left, which means 50 minus 34, which is 16%. Another example, let me see, I will remove this now. What if I'm asking you to find the probability of 22? What I will do, I will look at the main stops here, or the accurate numbers. I know that this is a 22, which means I want to find the area all the way on the left side of this line here. So I know now when I stop here, this is the whole side here is a 50%, while from here to here is a 34%. So to stop here, I will add both, so it will be 84%. So this was why we are using the normal distribution graph to calculate the probability, and it's very easy now. Now, let's say why we will use the coded data or the standardized data or the z-scores, whatever you call it, why we are using them now. If I'm asking you in the same question here to find the probability of 19, now what will happen here, I will check all of these numbers. I have here 20, 19 should be on the left side of 20, here is 18, but I don't have a 19 on any of the lines here. So in any of these lines I don't have the 19, so I don't know what is the exact probability. We know only these percentages for only the stops here, for mu minus sigma, mu plus sigma, and so on. However, for 19 we don't know how to calculate this. So to calculate the probability of 19, as we said, we don't know where is it exactly, but I know it's somewhere between 18 and 20, and to be honest, it's exactly in the middle. So some of you will think, as it's exactly in the middle, it means it will be like somewhere here, which means we will cut the 34 into halves, so it will be 17 and 17, which is absolutely wrong. Why is that? Look, ya shabab. If I have this part of the graph, if it's a rectangle, which means if I will cut it exactly from the middle, if it's a 34% and I cut the rectangle from the middle, as this is a regular shape, it will be in this case 17 and 17 percentages. However, as you can see, this is not a rectangle, so when I cut it from here, I can't say what percentage on this side and 1% on this side, and this is the curve. So it's very obvious that this part is bigger than this part, but I don't know what are the percentages exactly. Okay, type in this case what we will do to calculate the probability in this case, so we don't have any other way to do this, but however that's why they created this z-score values here. So in the z-score values, we still have the same percentages. However, we have numbers like 0, 1, 2, 3, -1, -2, -3. From where did we get these numbers? Remember, يا شباب, to code the data, we have a rule like to find the z-score, we use the rule that says z equals x minus mu over sigma. Am I right? Type. In this case, what will happen? Let's say we said that in the middle here, in this x score, we have a mu, right? Type. If now I want to use the z-scores, what I will do is I will assume that x equals mu. So in the z-score, if I want to find the value in the middle, I will say x is standing in the middle. It means it's the same as the mu. So it will be z equals mu minus mu over sigma, which will be 0 over sigma, and the answer is 0. That's why we have here the first value as 0. Type. Now, if I want to find the next value, like let's say on the right, for example here, what will happen is I know now that the second value of x is mu plus sigma, so I will replace x now by mu plus sigma minus mu over sigma. It's very obvious that mu will be cancelled with negative mu. We will come up with sigma over sigma, which means 1. That's why we'll find here number 1. And to be honest, you can keep substituting by mu plus 2 sigma. You will find the answers 2 and 3. As you will see all of these numbers, if you will substitute by mu minus sigma, you will find it as a -1, -3, -2 and -3, and so on. Type. In this case, ya shabab, I can change any value from an x score, which I can not, like the 19 here, I can't find it. And what we will do, we will code this data. So let's say I will find the z value for the 19. So I will replace now x by 19 minus mu, which is the mean, which here is 20, over sigma, which is 2. If you will do this here, 19 minus 20 is a -1 over 2. Always write the z-score as a number in a 2 decimal places if possible. So in this one, -1 over 2, you can use your calculator, or it's very obvious, it's a -0.5, but usually, as I said, ya shab, write it always as in 2 decimal places. So if I have an accurate number like 5, you will add a 0. If it's a very long decimal, round it to the nearest 2 decimal places. Then we will go to the table of values, and the table of values will help you to find the exact percentage. That's why we use the z-score, because we will have table of values that will help me to find the exact probability or percentage where the z-score equals the given value here. Now, let's move to the questions and see how it works. So, as you can see, in the first type of questions, as I said earlier, which I do not expect you will see in the exam, is just to find if it's a writing part, it's just to find the z-score. It's a very simple question, so I don't think it will come like, maybe it's a part of a question, but not the whole one. So there should be like A, B, and C, so you can solve more than one thing here, or it will be a more complicated question, because this is a very simple thing. You don't have to do anything. Just I will use the formula to convert from an x score to a z score. So what I will do, z equals, I will use the rule. So x, which is the value of x here, is a 24, minus mu, which is 19, divided by a 3.8. You put this on the calculator, it will be, approximately equal 1.316 something, so it will be 1.32. So as I said earlier, Shab, always put the z-score in 2 decimal places. Type. Did he ask me to use the table of values to find the answer? No, he didn't. He just said find z. But in the exam, he may give you one part, like this is part A, then he will ask you in part B, find the probability when z is smaller than this value or something. Okay? It will be obvious in the next example here. Like, let's see this one here. So this could be as a separated part B. Used a standard normal distribution table to find the area under the normal curve, So what we will do in this question, I just, Yashab, you know, and I've shared this with you earlier, and you should receive this in the final exam. The 2 tables of values, one for the negative scores, one for the positive scores, for the z-scores, and you will just look up the value that is in the question here. So let's see. It says, again, use a standard normal distribution table, which is here, to find area under the normal curve within the interval z smaller than. Okay يا شباب. طيب when z smaller than negative 1.18, as we said, it will be in 2 decimal places. I just, يا شباب, if you remember, it's a big table, but I cut the part that we will need only to show you how it works. Actually, I will take the whole number and 1 decimal place. This will appear in the first part here, in the first column. Then all of these values will be used to find the second part, or the second decimal place. So I will go look for negative 1.1 first. Negative 1.1, here we go. So this is the negative 1.1, and then the second decimal place is 8. So I will go all the way in the top to find the 8, as you can see here, and I will find the intersection of both. So if I will go all the way from here and all the way from here, so you will find the answer will be this value. So if I look up in the table of values, I will find negative 1.18. This is how it works. So the answer should be equals 0.119. You can just put 00, or it's not important to show the 2 zeros here. That's it. So you will, again, this is a normal question. You will look up the search for the value in the given table from the left side, find the negative 1.1, then I want the 8, so I will go all the way until 8 and write this as the answer, and that's it. Right. Let's see this question. I expect one of these questions like this one comes in the exam, because here he will not ask you to find the z-score. However, you must find it, but he will not tell you in the question find the z-score. So what happened here is, it says the number of daily hits to a local news website is normally distributed with mu equals 98,452 hits. So this is the value of mu, and sigma equals 10,325 hits. Find the probability that the website will get at least this number. Type. The most important thing, ya shabab, at least means smaller than or a greater than. So at least is greater than, which means this is the minimum value and more. Type. So it could be written in this form. This means the probability when x is greater than this value. Type. In this case, ya shabab, the first thing to do is to find the z value to standardize the data or to code it. So x here, like I will need a longer fraction here. I will use the rule. X is the value given here, so it's a 100,000 minus mu, which is given here 98,452, divided by sigma, which is 10,325. Right now, ya shabab, you need to use your calculator to solve this, which will be approximately equal, as we said, I need 2 decimal places, so I will take 0.15. Alright, don't forget, ya shabab, we put the answer in 2 decimal places to be able to find it in the table of values. Type. So I found the z. Now I will change the question, ya shabab, from the probability when x greater than 100,000. Now I found the value of z. I will replace now the values from x to z, which means I will rewrite the question again. Now it will be the probability when z greater than 0.15. This is what we call it standardized data, or coding the data. And instead of using x greater than this value, I will use now the z values, probability of z greater than 0.15. Type. I will have to stop at some point here, then we will go to the table first. Remember, ya shabab, we said, and as you will see this picture in your table, it like stresses on if you have any value like either anywhere on this graph, these values given here are showing the left side when it's a smaller than the given value. So let's say, for example, this is a, so this represents z smaller than a, and all of the values here are z smaller than the given value of a here. For example, like if this is 2, so z smaller than 2. Type. What if I want to find z greater than 2, or the probability when z greater than 2? What I will do, remember, ya shabab, we said earlier the total area under the table here, under the graph, sorry, is 1. So which means both of these, like if I will add the left side and the right side together, the answer must be 1. So I will say, for example, probability when z is smaller than a plus the probability when z greater than a, it will be 1. Smaller plus greater, this represents the left side, this represents the right side. Both of them must be of a total of 1. This means if I want to calculate the probability of z greater than a, I will move this to the other side. So the probability when z is greater than a, directly what I will do, I will say 1 minus probability when z smaller than a. And this will be the rule we will use in all of these types of questions when I use a greater. Okay. Now I will remove this. Let's go back to the question. So if you have this question written like this, we change first from x greater than a value. We use the coded data z greater than 0.15, and you should write what? 1 minus the probability when z smaller than 0.15, because we need what completes this to 1. So I will do 1 minus the smaller part here, or the left part. Type. So I will write here 1 minus. Now I want to go to the table of values, because this is the smaller sign here. This provides is the information provided by the given table. Now I want to go to 0.15. Remember, Shab, we will take only the first decimal place and the whole number, 0.1 on the left side, 0.1. Here we go. Then I need to match it with the 5, so I will go all the way here. I want this 5, so I will go from here like this and go from here. So this will be your answer. So it will be 0.55962, and you can just subtract by the calculator. Let me just do this very quickly. So 1 minus 0.55962. So the answer will be 0.44038 type. This is could be the solution, and that's it. We stop here. But what if you said write your answer as a percentage? What I will do, I will just multiply by 100, which means move the point 2 steps to the right. So it will be 44.038%. But what if he said write your answer in 2 decimal places and then convert it to a percentage? It will be approximately equal 0.44 only, then which means it's 44%. So it depends on what he will ask you to do in the question. If he didn't mention anything, I should stop here. That's it. You don't have to change it to a percentage to do anything. You have to leave it that way. What if he said as a percentage, multiply by 100, and in this case this will be the answer. What if he said into 2 decimal places? So this will be the answer. Okay, Shabab? But the questions will be as simple as that. Just code the data, use the this formula to change from x to z score or the z value. Then don't forget, if it's a smaller, find the value in the table directly. If it's a greater, I will do 1 minus the smaller, the p smaller than the given value. Type. These questions are totally similar, like finding the z value, just direct substitution. These 3 questions are similar to the ones we have just did. So what we will do, as I said, Yashab, I cut part of the table to solve. So I will do this very quickly. If it says z smaller than, which means I will go directly to the table. I will take the whole number and 1 decimal place and stop here. So negative 1.5, negative 1.5, it's there. And then I want the second decimal place to be a 6, which means I will go here. So all the way from this side and from this side, they will intersect here. So which means the answer is 0.05938. That's it. For this question, if z is greater than this value, what we will do, if it's a greater, remember, I will write equals 1 minus z smaller than 0.58. If it's a greater, I will write 1 minus when z is smaller, because this is the value I can find in the table. Now what will happen is, we said 0.5, and I will stop here, go to this side. Here is 0.5. Now I want the second decimal place to be 8, so I will take this one Now it means I will go all the way from here and all the way from here. It will be this value. So I will just do now 1 minus 0.71904 and find the result, whatever the result is. Okay, Shabab? The last question here, what if the z value is between two numbers? What I will do, I will solve each of these separated. Like I will look just for the table, for the values in the table, negative 2.2. Negative 2.2 is here. Now I want the second digit to the second decimal place is 9, which means I will go all the way until the end because the last digit I know always is 9. So this will be the solution. So I will write here 0.01101. Now I will go to the second value here, 2.7. So as you can see, we have a 1 in the negative table and we have 1 in the positive table. So I will go now here and I will find 2.7, which is here, and the second decimal place is 6, which means here. So I will go from this side and I will go from this side. This will be the intersection value, so this one will be 0.99711. Now what I will do in this case, I will subtract both starting from the end, like 0.99711 minus 0.01101. So let me do this very quickly. The answer should be 0.9861, I think. You can check this with the calculator if you want, and this is how it works. So this is all from this part, ya shabab. All right. The next question, the free response, and the last one in the EOT, question 25, module 9, lesson 5, graph and analyze tangent functions. So just before we start, ya shabab, I just want you to answer these two questions so that we will be able to proceed and understand the other questions. What is the period of the tan x function? What is the period of the tan x functions? If you remember, Shahab, we mentioned this before. For the sine x and cosine x, the period for both of them is 360 degrees. Which means the part of the curve that is going to be repeated, or the whole graph will be repeated every 360 degrees. All right. And what about the tan? The tan actually will be repeated every 180 degrees. This means the period of the tan x function is 180 degrees. So this is the first thing to take care of or to keep in mind. It's not the same as the sine and cosine. The repetition in the tan x will happen every 180 degrees, which means the period of the tan is 180 degrees. All right. What is the equation or equations of the asymptote? So before we do this, I want you to solve this question. You can just use your calculator. I will find tan negative 360, tan negative 270, and put these on the calculator and see what will be the answers. So let's say, for example, negative 360, if you will put it on the calculator, it will give you a 0. Then when you will put a negative 270, it will give you an error, which means this is undefined, right? So negative 180 will give you 0, then undefined, then 0, then undefined, 0, undefined, 0, and so on. All right. So I wrote it for you here so we can proceed with this. Remember, Shabab, if the function is undefined, first of all, why it will be undefined here? Remember, Shabab, the tan x equals what? Equals sine x over cosine x, which means the function will be undefined when the denominator will give you 0. So the denominator cannot equal to 0, because in case if we have a 0 here, it will be undefined. And we know that cosine equals 0 with these values here, like with 90, like cosine 90 is 0, cosine 270 is 0, cosine negative 90 is 0, cosine negative 270 is 0. So that's why when we calculate the tan, when we will divide by a 0, the function will be undefined. And if you remember, we explained this already in the rational functions. In the function is if the denominator is 0 and the function is undefined, this will be represented by an asymptote on the graph, will be represented by an asymptote. So this will be as well an asymptote. So all of these يا شباب will be asymptotes on the graph. طيب. For example, now if I'm, as you can see يا شباب, this is the tangent or the tan theta or tan x graph function drawn. So what will happen is these values, like when the function equals 0 here, this means if this is representing a y, and when y equals 0, this means this will be the x intercept. So same as this one, same as this one, same as this one, same as this one, which means we will have a point for the intercept, then an asymptote. So I will start from 0 here and show you. For example, we have here the point 0 and 0. So I will start from here and go right and left. So starting from 0, then at 90 we will have undefined, which means we will have an asymptote, as you can see. So we have the first asymptote. Then we will have a 0, as you can see. 0 asymptote, 0 asymptote. So 0 asymptote, 0 asymptote, and so on. From the left side, the same thing. Starting from the middle, 0 asymptote, 0 asymptote. So which means the asymptotes will start from, like, let's say I will start from the 0. I will leave a 90 and draw an asymptote, then it will be repeated every 180, every 180, and same from the left side. 90 from here, then every 180 we will have another asymptote, in this case time. So which means the first asymptote يا شباب, the equation of the asymptotes, as this is a vertical line, it will be, if it's a vertical line, it will be x equals, right? So for example, this line here is x equals 90 degrees, or x equals 90. So I will start from the 90, then the repetition will happen every 180. Like we start from 90 as the first asymptote, then the repetition happens every 180 degrees, every 180 degrees. It means leave one square, then leave 2. This is how it works. So x equals 90 plus 180 type. How to show that this is a repetition? We will add here n. So the asymptotes will be x equals 90, and this is the first asymptote, and it will be repeated every 180. But to show a repetition, we will add here n. So I can change the value of n to find the other asymptotes. I have to explain where n equals, or n represented by. Let me write this here. It will be all positive and negative and 0. So n is an integer. N is an integer. Like for example, if I will put here n equals 0, this will be a 0. So this will give me the first asymptote at 90. When I will put in here, when I will put n equals 1, it will be 1 times 180 is 180 plus 90 is 270, where we will have the second asymptote, and so on. N could be 0, 1, 2, 3, 4, or negative 1, negative 2, negative 3, negative 4, and so on. So n is an integer, could be replaced to find all the asymptotes of this function. So this will be the equation of the asymptotes of the tan graph. Right? Now let's go to the questions and see how the question will come in the exam. As you can see, Shabab, here he will ask you to find the period, asymptote, x-intercept, midline, and transformations of y equals tan 3x, then grab the function. Before we start, we have this form here of the tan function. This is we have more than a form, but this is the one we will be using, because all the questions you have here are not moving right, left, up, or down, which means there is no vertical shift. However, we will have a change of the period here, so we'll see this in a minute. So as usual, ya shabab, the value of a here will be representing two things. It could be representing a reflection when a is a negative sign, has a negative sign, or a is a negative quantity, and it will control the dilation, or let's say dilation, or we can say the compression or the stretching of the graph, while b here will be representing the change in the period, the change in the period, the same thing we have done with the sine and cosine type. Remember ya shabab, always we said the period equals, in sine and cosine, it was 360 degrees over b. Am I right? The period in sine and cosine was 360 over b, which means 360 is the original period of the graph divided by the factor that is multiplied by x. However, in tan, it's not a 360 anymore. We are using here 180 degrees. So the period for the tan will be 180 degrees over b. Now let's see, I want to grab this function, so I will go to this one here. Actually, look at the a first. So a here does not exist, which means a equals 1. Like there is no number here, it means 1. It's a positive 1. It will not affect by a compressing or stretching a graph, so ignore it for now. Now I have here the value of b, so b here equals 3. So before I start what the first thing to do is to find the new period of the graph. So the period we said will be, as this is the tan function, so it will be 180 degrees divided by b, which is 3. So the answer is 60 degrees. So the answer is 60 degrees. Right. One very important thing, Shabab, and I hope you understand this or you realized it from the previous question. So let me just move one step back. Look, usually to draw the asymptotes, I need to decide what numbers I will use here. Like for example, 0, 90, 180, 270. So it's very obvious we are counting by 90s to find the numbers. So the squares here, or the stops, or the points of on the x-axis I used, every time we are counting by 90. So I will give you a trick here, and from the other side still 90, 90, but by subtraction, so subtracting 90 every time. All right, so which means that every point here will be counted or like moved on a sequence of adding 90s or subtracting 90s. It's the same thing. Why especially we have chosen 90? This will make the drawing a way much easier when we graph it. Like how we will find the number that I need to use here and count by. Usually, Shab, what you will do is period divide by 2. So to do this, I will do the period divide by 2. This is for the tan function. So if I have here 180 as a period of the tan, divide by 2, the answer is 90. So which means I will start from 0, then count by 90s on the right side and negative 90s on the left side. Now, let's apply this rule here, and I will show you why I have done this. So now, the period is 60 degrees, which means to choose the numbers I will use here on the graph, I will do 60 divided by 2, which means I will be counting by 30 degrees. I will be counting by 30 degrees, which means, Yashab, I will start here. This is the 0. And actually, to make the graph easier to draw, I will leave 2 squares instead of 1. So I will put the points like this. So I will put the points like this, Yashab, to make the graphing easier. Someone will say, what if I will put it every point? Is it a problem? No, actually it isn't. But if you will leave 1 square, so you will have to write the numbers on 1 square. But if you can imagine, if I will write here 30, then 60, the numbers would be very close. So I will just leave a space. Is it wrong? No, at 100% correct. But if you will do it every one, it's still not wrong. You can choose whatever you want. But I'm choosing 2 squares, so I will have a space to write things here, and the graph will be more clear. Now we said, go back to this part. We will be counting by 30s, which means I will start with the first point here. 30, 60, 90, 120, 150. On the other side, negative 30, negative 60, negative 90, negative 120, negative 150. Of course, Hashab, all of these are degrees. All of these are degrees, all right? So you have just to show these are degrees. Type. Now, after putting these numbers, I don't have to put numbers on the vertical axis. You'll see this in a minute. Now, we said, ya Shabab, the most important thing before I graph is to put the asymptotes before I start drawing or doing anything. Type. Now, we said, ya Shabab, the first asymptote always will be here. That's why we are dividing by 2. We can say the first asymptote will be dividing the period by 2. So that's why the period here is 60, dividing by 2, the answer will be 30, which means, Yashab, I will draw the first asymptote at 30. All right, so I can bring the first asymptote and put it at 30. Then يا شباب, if you remember, we will move like first one 30, then leave 1 point, then the other point is at 90. So the second asymptote we will put it at 90, because if you remember, this is the x-intercept, asymptote, x-intercept, asymptote, x-intercept, and so on. So the third asymptote will be here. Then on the other side we will have here the same thing at negative 30, at negative 30, and then we will have one at 90, then we will have another one at 100, negative 150. يبقى again يا شباب, the asymptotes will be drawn that way. Start 0 is the first x-intercept, then asymptote, x-intercept, asymptote, x-intercept, and so on. Same thing from the left side. Right. Now, how we will graph this, as if you remember, we start as this is an asymptote, we will start all the way from here, and I will go down. The x-intercept is here, then I will go, sorry, actually, as you know, I'm drawing on the tablet, so I'm trying to do my best here. So we will draw it like this and go down. So this is how you should be graphing it. Actually, if you're drawing this on paper, it should be better than mine. So again, we will do the same thing, having the intersection here and then go down. Same thing, having the intersection here and then go down, and try to be as accurate as possible. Sorry. It's not easy to draw here, but I'm sure you understand the main idea. This is an asymptote, then we will cross it from here and go down. And don't forget, Yashab, to put the arrows for all of the parts of the curve. Don't touch the asymptote. Maybe I touch it here a bit, but like if you are on a paper, it should be as if you can see this. Sorry, as if you can see this. This is how the graph should look like, going like this, smooth. And if you are drawing with the pencil on paper, it should be better than mine here. But here is the main idea. So the first thing, Yashab, again, one last time, when you have a value of b here, we will divide the period by 3, which is 180, to find the new period of this graph, which is 60 degrees. Time. We will not be counting by 60s. We will need to find what will be the first asymptote. So the first asymptote will come from dividing this new period by 2, which is 30. So I will be counting by 30s here. So in this case, I will put the asymptotes like this is an x-intercept, asymptote, x-intercept, asymptote, and so on. Now, so let's say what will happen here in this question, or what is the change? Remember, we have y equals ax, a tan bx. Now we have a change of the value of a here. As you can see, we have a negative third. So a equals negative 1/3. Actually, Shabab, don't confuse yourself with the value of a at all. Like, let's ignore it for now. I will go back to this later. Now I will go to the value of b. As you can see here, the value of b equals 2. So what we will do to find the period of our function here, I will divide the original period, which is 180 degrees, by 2, which means the answer will be 90 degrees. Right? So this is the period of the new graph. To find the first asymptote, what we will do, we will divide this 90 by 2. So I will count by 45 degrees. This means, Yashwab, the numbers I will use here on the graph, for example, remember, I will start from 0, then I will count by 45, but I will put the points first before I start doing anything, to be sure that I'm putting the points correctly. As I said, I will count by 2 squares. If you will do by 1 square, it's still correct, but I'm just leaving spaces to be able to show you and to draw better. So now I will be counting by 45, which means this will be 45 degrees. The negative 1, add every time I am adding a 45. You can hold just your calculator and add 45. Add 45, it will be 90. Add 45, it will be 135. Then add 45, it will be 180. Add 45, 225 degrees. On the left side, I will do the same thing. Negative 45, negative 90, negative 135, negative 180, negative 225. The next one should be 270. Every time we are adding either or subtracting a 45, or we just add and mirror these on the other side by the negative sign. Alright, يبقى this is the first thing. And we said يا شباب, this will be the first intersection. Then we will have, as we said, you have to draw the asymptotes first before you think of anything. Even the value of A, I will leave it until I draw the asymptotes. It will not affect the asymptotes. طيب. In this case يا شباب, I have to bring the asymptotes. Now يا شباب, now the first asymptote we said x-intercept asymptote, x-intercept asymptote. So I will do the same thing. Actually all the graphs will look similar. So here is the first asymptote, here is the second asymptote. I will leave x-intercept asymptote, x-intercept asymptote, bring it here. Now again from the other side, the first asymptote is here, then leave x-intercept, then an asymptote, x-intercept and asymptote. I will bring the last one here. So we have the same asymptotes. So as you noticed يا شباب, I'm placing the asymptotes. If you will go to the previous question, even here, what you will notice, the asymptotes are in the same place. What is it changing is the number we are counting by every time and where the asymptotes are standing. That's it. So it looks like all the graphs will be similar except for the numbers I will be using here. That's the main idea. Now let's go back to the value of A. We do everything, we put the asymptotes, then before I start graphing, I will go to A. Why is that? First of all, A here is negative. So you normally would draw the graph, we said from start from the right top to the left bottom, right? If A is negative, it means I will start from here and I will go from the left to the right side like this. Okay شباب, طيب. What this is about the negative. What about the 1/3 here? We say يا شباب, if this number is less than 1, this means the graph will go closer to the x-axis. This will be the only change happening. But what if this number is greater than 1? It means it will go further from the x-axis. This is how it works. I will show you this in a minute. Again, just a very quick thing about the tan here, but ignore the numbers on the x-axis. This is the graph of the tan x. If I will multiply tan like by 2 tan x, what will happen here? It will be like it will go further from the x-axis, like I will start rotating earlier. Type. What if it's a 0.5? What will happen? It will come closer to the x-axis. It means I will start rotating and reflecting like before I reach the x-axis. So I will show you the 3 together, as you can see. So the red one in the middle is the normal tan x. So this one here is tan 2x. This one here is 0.5 or half tan x. So this is the difference between the 3 graphs. So the number that is outside will control how the graph is compressed or even stretch it to go back. All right. So if I will go back here again, so if this is 1/3, so let's just show you something very quickly here. So if I'm, for example, these are like any two asymptotes, like let's say this is the first asymptote, this is the second asymptote, and we have a point in the middle where the graph will cross the x-axis. For example, this is the normal tan graph, the normal one. If I will do, for example, 2 tan, what will happen? If it's a 2 tan, let me choose a different color here. So if I will do 2 tan, so in this case, this graph will start rotating earlier, like it will come like this, or let me just try it, it will come from here, like there will be a difference of the graph. But what if it will be 0.5 tan or half tan or a fraction, third tan? It will start rotating at a late point like this. Right? So this is how it looks like. So this is the difference between the numbers we multiply, like compressing the graph or stretching the graph. Alright, let's go back here now, and if I want to graph it, just keep this in mind. First of all, this is a negative, so I will start from the top left, and this number is compressing the graph, which means I will start rotating at a late point here. Alright, so right, and I will put these lines here as again يا شباب, if you will be drawing this on the paper, you should be drawing better than me, okay, and so on يا شباب. So I will try hard, like it's not easy, so just I hope you understand how it works here. All right, right. Now completing the solution of this question, we have to find the period. Already we completed the period as 90. Asymptotes. All right, to find the asymptotes, remember we said the asymptotes will be given using the equation y equal the asymptotes are vertical lines, like the first asymptote here is at 45, so it's x equals 45 degrees. The second asymptote is x equals 135 degrees, and x equals 225, and so on يا شباب. X equals negative 45 degrees, same thing. Right. To write the equation, remember يا شباب, so we will write x equals, the first asymptote, remember, is a 45 degrees, and it will be repeated, remember, start first one with 45, then it will be repeated by adding the period, which means every time we will be adding 90 from this side, or like subtracting 90 going to the other side, subtracting 90 going to the other side, which means the and so on, like the same one here. So which we can say we start with the 45 degrees and it will be repeated every 90 degrees. طب every, we said يا شباب, every 90 it means I will add here, and you have to explain that n is an integer. You have to write this to show what is this n here. So n is an integer, right? So we can say that we can rewrite this as a rule from now on, which means I can say that the asymptotes usually will be x equals period, the new period of course, over 2 plus period multiplied by n. So this could be the rule we use for the asymptotes. You x equals period over 2 plus period multiplied by n. So let's apply this here. The period here, the new period is 90. 90 divided by 2 is 45, plus period multiplied by n, which is 90 multiplied by n. This could be the rule to solve any question from now on. Okay, شباب. This is for the asymptote. What about the x-intercepts here? To find the x-intercepts, remember, what will happen? It's after 90, then after 90, then after 90, which means x equals, what is the first intercept? The first intercept is 90, and it's 90 degrees, and it's repeating every 90, which means directly I will do 90n, where n is an integer. So we have here x equals, because starting with 0, it will be repeated the x-intercept every 90 degrees, so it will be 90n. How can we apply this as a rule? We can say the x-intercepts will be x equals period multiplied by n, directly period multiplied by n. So we can simply say it will be x equals period multiplied by n. So this is for the x-intercept type. What about the midline? The midline, actually, if the graph is not moving up or down, it will be always the x-axis, or actually I don't prefer to write it as this. We will write it as y equals 0. Okay, شباب? Now, what about this question here? It says a y equals tan 5x. To be honest, شباب, it will be exactly the same thing. We don't have a value of a, we just have a 5 here. So I will just help you from now on to just put the asymptotes and see the value of b and what effect it will have. So let's say b here equals 5. The first thing, how to find the period. The period will be 180 divided by 5 equals 36. So the first thing is that the new period now is going to be 36. To find the first asymptote, or the equation of the asymptote, let's apply the rule يا شباب we have done here. So the asymptotes will be coming from x equal period over 2 plus period multiplied by n, which means it will be 36 over 2 plus 36n. طيب 36 divided by 2, it means 18, and it will be 18 plus 36n. Alright, so which means the numbers I will be using here, so let me put the points first. 1, 2, 3, 4, 5, and on the other side we will have like the points. I'm like highlighting the points first before I start putting the numbers. Now I will be counting now by, if you remember, we will be counting by the period divided by 2, which means I will be counting by 18. As you will say, the first asymptote will be 18. So every time, ya shabab, every time we will be adding, so the next number here will be 54, then adding 18, it will be 72, then adding 18, it will be 90. So in the other side, negative 18, negative 36, negative 54, negative 72, and negative 90. And now I can start placing the asymptotes. I can start placing the asymptotes. So here is the first asymptote, here is the second. If you remember, leave 1, then leave 2, so the third asymptote. And on the other side, leave 1, and then every time we will be leaving 2, because if you remember, 1 for the asymptote, 1 for the x-intercept. So this is how it works. Type. So now it's very obvious that these will be the correct places of the asymptotes using this rule, and this is already the equation of the asymptotes now, which means we answered this part. How to find the x-intercepts? Remember, we have here the rule x equals period n, which means x equals 36n. In the period here is a 36, so x equals 36n. This represents the intercepts. The midline, the graph is not moving up or down because there is no value of k here, h and k. If you remember, we don't have any change in h and k values, which means the graph is not moved up and down, which means the midline is y equals 0. And this will be representing the equation of the intercepts. For example, if x equals 0, the answer will be 0. So this is the first intercept, x-intercept. Type. If x equals 1, it will intersect at 36. X equals 2, it will be 72, and so on. To graph this function, we don't have a value phase, so we will draw a normal graph from this side and going down like this, okay shabab, this is how it works, and complete in all the other places here. Okay, I don't think there is anything different, so all of the questions are exactly the same. Just find the value of b, you find the new period, find the asymptotes, draw the asymptotes, and so on. Thank you so much, ya shabab. Alhamdulillah, this is the last question in the OET. All what you need to do is to study hard, focus during the exam, and inshallah all of you will get the full mark. Hope you all the best of luck.